Okay. Ready. Not zero path manipulation. What is this? 0, 15, not zero path manipulation. What is the new things happening on there? Okay. So this is my topology right now. So we can take example. These are the two different paths we have. For example, this is the user are sitting behind the R1, right? The user are sitting behind the R1, and to this user wants to reach to this network, right? So mic is on. This user wants to reach to this network. So there is a two path. Either they can go via the this way, right? Or either they can go via the this way. See, by default, what happened? By default, what happened if your metric is same, right? By default, what happened if your metric is same? By default, what happened if your metric is same, right? Then it perform the load balancing. That we know, right? By default, if the metric is same, then what happened? It will perform the load balancing. It will send the traffic via this way as well as. So if this user said, hey, I want to ping any traffic, doesn't matter, right? If you have ICMP protocol, if you have a STTP1, any traffic, it will do the load balancing. It will send the traffic to this guy, and then R2 will send the packet to this guy, right? And then same thing, R1 will send the packet to this guy, and again R3 will send the packet to this guy. It do the load balancing, R1, if your metric is same. In case, take example, right? Your metric, I'm going to tell this guy, okay, from here to here, I'm going to taking the 5,000 metric to reach this person, and from here, I'm taking the 6,000 metric, right? What happened? This will become my best path, or this will become my second best path, right? So what happened? R1 will always send the traffic to from the R2, always, not from the R3. R3 is behave like a backup path, right? Somehow, if the primary is not available, right? Somehow, if primary is not available, then R1 can switch the traffic from the R3. But if R3 comes, R2 comes up, right? If the primary path comes up, right? What happened? My traffic will go follow by the best path. But take example, I want to manipulate it. For example, I need to, on the router number 2, I need to upgrade the iOS. Or upgrade the iOS version. So I need some time, right? Or maybe anything, I want to change the path, right? I want to say, hey, I want to send my traffic not from the R2, I will send the traffic from the R3. All the traffic, I'll send to the R3 for this two network. In that case, what happened? Either you can change the delay value, right? Either you can change the delay value, or either I can change the bandwidth. Because by default, if you have a look the k values, which one I'm going to use for the which one I'm going to use for the battery calculation. By default, we have a K1, we have a K2, we have a K3, we have a K4, and we have a K5, right? So K1 is what? It's a bandwidth. K2 is what? It's a load. K3 is what? It's a reliability. Not reliability, it's a delay. And the K4 is reliability, and K5 is empty, right? So by default, which value I'm going to use? I'm going to use the bandwidth and delay for the metric calculation, right? And this value should be 1 always. This will be 0 0 0. To send the traffic, I'm only going to use calculate the metric. I'm going to use the bandwidth and delay over there. Right now, what happened? I get the metric 5,000 to reach this guy. I'm getting for the 6,000 for this guy. So I'm going to make the lower is always best, right? So what happened? This guy is the best one. But take example, right? Take example. I want to make R3 is the best. Just manipulate the delay and bandwidth, right? And I can achieve my output. If you have a look, I'll do one thing. I'm going to add some more route behind the R4, right? That's a slash 24, right? If you look over there, R1, so where's R5 now? R1, so IP interface video. Also the first configuration of IP configuration, right? So these are IP configuration we have. Okay, I don't have right now EIGRP right now. I think so. R2 as well as we have proper IP addressing on R2 as well as, right? If you look the R3 now, R3 also looks cool, right? And R4, fantastic, right? Let's create the one more loop back. That's I told you that we have one more loop back over there. Make it slats. Done. So now doodle one. Let's configure the EIGRP. By default, what happened if the metric is same, it does the load balancing, right? If you see do network 0 dot EIGRP number 1, network 0 dot config channel dot EIGRP number 1, network 0 and R4. Done. Come on. Okay, already configured. 1 minute. Okay, it's already, I think so. There might be. Do show IP EIGRP neighbor. Yeah, already is there. So if you see do show IP root EIGRP, what happened? By default, it does the load balancing for this network. These are the networks behind R4, right? I'm talking about this network right now. Okay, for this network, right? For this network and for this network, it's doing the load balancing. Why? Because the metric is same, right? I can send the traffic. If any packet is coming for the, doesn't matter if we have a x dot x dot x dot x dot source, right? Destination is 4.4.4.4.4.4, right? Because always we are going to perform the destination lookup, and that's why it's called as our destination based routing. You can do the source based routing as well as that comes in the policy based routing, right? We'll see in the advanced lecture. But by default, what happened? The router does the destination based routing. And based on that, what R1 will do, R1 will send the traffic to the R2 according to the routing table, right? You can see that this part and R2 as well as. So it will send the packet to the R3 and R2 as well as, right? But what I want out there, I want to make R2 as a base because see, load balancing is not a good solution always. Load balancing is not a good solution always. Because take example, if you have a voice traffic, what voice traffic? If you take example, this is my 10 Mbps link and this is a 1 Mbps link, right? And I'm getting the same metric out there. What do you think? Is the load balancing is good? No. If you have voice traffic, if the voice traffic will follow this path, they will face some delay, right? So load balancing is not a good solution always, right? Sometimes it's good, sometimes it's bad. Depend on the requirement, depend on the topology, right? Depend on the network setup. But right now, in this case, my different bandwidths are there. This is not a good solution. So what I can do, I want to make R2 as a best right now. How do I do that? Change the void interface 0/1. What's the different delay value over there? Sorry, what's the default delay value? The default delay value is a 1000 microsecond, right? It means that 100 is configured over there and 100 is configured. If you configure the 100, it will convert into the microsecond, right? So 1000, it multiply by 10. If you're going to configure 10, it will become the 100. And if you're going to configure the 1, it will become the 1000. And if you're going to configure the 1000, it will convert into the 10,000. So it's depend, right? So right now, what I can do over there, I can change the delay value, right? I'm going to make this guy, by default is 100 over there, or we can say the 1000. I'm going to make this guy the 10,000 downside. So what happened? I'm going to make R2 as a best. So interface 0/1 delay what? 1000. It converts into 10,000, right? So if you see 10,000. Now what happened? R1 is giving the preference to the R2, right? Because from this side, I'm getting the lower metric. See, now R1 is pointing to R2 to get the 4.0 and 44.0 and 172.16.1.0 network. Awesome, right? Again, for example, I want to make R3 as the best. What I can do, I'm going to change make the lower delay. I'll say the delay is 1 now. So if I'm going to configure the 1, what happened? It converted into the 10. So now this side is 10, right? Awesome, right? And if you see do show IP route EIGRP, I'm having a best path is what? R3. Same way you can change the bandwidth and you can manipulate the path. But do you know one thing over there? I'm not telling you this is the bandwidth and delay is a bad solution to change the path. I'm not saying like this. It's a good solution, right? Bandwidth and delay. A very simple commands are there. But if you have a look the output, this is my what? This is my primary path, right? And this is my what? Secondary path. And if you see the output, if I'm manipulating the bandwidth, right, or delay anything value, it's changing the path for every person, right? Same way. I'm changing the path for every person. And that's not a good solution. Because take example, I'm going to make R2 again best. What happened? I just need to say that delay will be what? 1000. So now R2 will become the best, right? Because now delay is about 10,000 over there. And delay is 1000 only. So lower is more preferred, right? So if you see now, do show IP route EIGRP. Sorry. So what happened? I'm changing the path for the every network. This guy, talking about this guy, and this guy as well as. So tell me, I'm continuously sending my traffic to the R2, right? Because this is my what? It's my 10 Mbps link, right? And this is my 5 Mbps link. So I'm only going to use the backup path, right? I'm only going to use the secondary path if the primary goes down. Listen to me. I'm only going to use the secondary path if the primary goes down. So am I going to utilize this all resources? Am I going to utilize all these resources if the primary is available? Of course, buddy, not. You can't utilize, right? You cannot utilize all the resources over there, right? Because this is the 5 Mbps link, this is the 10 Mbps link, and if my working, this primary path is working fine, if my primary path is working fine, you cannot utilize the backup path, right? The complete resources is wastage. Because in my routing table, to get this network, all we have a 12 or 2, right? Understand what's happening over there? Problem. I'm not able to use, so totally wastage of the resources from the downside. If the primary is available, dude, you can't send the traffic. You cannot utilize the backup one. If I'm going to change the delay and bandwidth any value, it is changing the path for all the route. You cannot, right? You cannot one route. Like what I want, hey, to reach this network, right? To reach this network, I want to go by the R3 because I also need to utilize R3 only for this network, right? Only for this guy. Because it's not like that I'm not going to use the 5 Mbps link. I want to use this link as well. For this one, this path, this should be best. Or we can say that, okay, right now, I want to make this guy the best, simply. So that my all the traffic to get this network for this R2 will become the best path for whom? 4.0.0.0.0/8 and 44.0.0/8. And R3 will become the best for this guy. So I'm not going to manipulate this thing by a delay. Let's do one thing. Let me no delay. Let's make a default. If I'm going to say no delay, what happened? It comes in the default behavior. And now do show what? Do show do show interface fa0/1 include delay. It's a default one, perfect, and 0/0 as well as good. Sorry. So what I can do on R4 router, you can do on the same thing on R1 as well as I'm going to match the route first of all, right? First of all, I need to match the route, right? And to match the route, what I can use is here format, right? Done, and then access list to done. Now what I'm going to do, I'm going to use the routing HRP number 1 offset list. I'm just going to increase the metric value in the default one by using the offset list. For example, right now, listen to me carefully. Right now, R4 is going to advertise this route 4.0.0.0.0.0 and 44.0.0.0.0.0, right? Right now, R4 is going to iterate this route as a from this way as a 500 matrix. Take example, and also going to iterate 500 from this side, right? What I'm going to call, I'm just going to add the extra matrix over there, 5,000. On which interface? 0/1. So now R4 will advertise this two or 4.0 and 44.0 with the matrix is what 500 from this interface, and R4 will advertise this route 4.0 and 44.0 from this side what 5500. So which one become the best one? Lower one. For which route? So I'm just going to call the offset list and I say, hey, for ACL number one, which direction, out direction, which interface you're going to apply 0/1. Set the offset value. I say the offset value will be 5,000. So this offset value is just going to increase your matrix, right? Whatever the default matrix is happening, it will increase the it will add the this offset value in the into the default matrix. And now it looks good. If you now go back, let's leave it right now. And what I can do right now at the same time, I'm going to make an offset list to now out direction 5,000. You can take any value. I'm just taking the 5,000 right now. I'm going to apply on 0/0 now for this particular route. Now what happened? For this particular route, R2, R4 is advertising. Take example. Come on, man. For this particular route, R2 is advertising, R4 is advertising as a default matrix is 500 from this side and this side as well as, right? What I'm going to do over there, I'm going to apply on this particular interface 500 plus 5,000. What happened? 5,500 from this side, R3, R2, and 500 from this side. So lower is west. So R3 will become the west for this guy. And now wait for some time. If you do the same thing on a router number one, you can do the inbound direction because right now R4 is advertising, right? So it should be outbound. R4 is advertising, it should be outbound. If you do the same thing, you can do on R1 as an inbound. Now, if you go back to the router number one and have a look, to show IP route, I can see it. I got the output. I'm able to utilize both the link. And you see 4.0.0 is coming by the 2.2 that I want, right? 4.0.0.0, right? This one. You see 4.0.0 or R2 is best, and even for the 44.0. And for the 172.16 dot, R3 is best. This is how you can change the path for the particular. And this is the most important interview questions, guys. Most important interview question. Many person is facing this question. Many person. Hey, you change the path, right? How do I change the path? They will give you like this scenario, right? Okay, for this network, I want to use this one. For this network, I want to use this one. Tell me. You just need to understand the concept so you can easily solve any scenario. And if you're going to change the offset value, right? If you're going to change the offset value, it will affect on your delay component. The increment will happen in the delay, not the bandwidth. Right? So this is how, if for example, if you know do the load balancing as well as I can do the load balancing. For example, I want to like this, take example. Okay, I can see that for this particular network, I'm gonna do the load balancing. I can do that. If you want, you can do that. How do I do that? Just need to go on the router number 4. I call this guy into the AC level 1, right? Sorry, not AC 1. I remove this guy 4.0.0 from the AC. So what happened? Now R4 will advertise the default matrix to the R3 and R2. R2 will advertise the default matrix to the R2, R1, and R3 will advertise the default matrix to the R1. For this, only for this particular dot. So now if you see on R1, okay, yep, come on, yeah, see, guys, it's totally up to you, like how you're managing your network and how what are the scenarios, situation is coming, right?
Sir, can you explain again this
This
section?
one,
Yes. For load balancing.
I didn't do anything, right? I just removed because previously what happened, I called this 2% the ACL, right?
Right.
Okay, so that's why they are adding the route for 2%. They are adding the matrix for this 2%. I'm adding the matrix for whom? If you see ACL number 1. So in the ACL number 1, what route I'm calling? This guy and this guy,
Right.
right? I'm adding the matrix for 5,000 for this 2%, right? In the ACL number 1, this 2% is calling. I just remove this guy now. So if I'm going to remove this guy, what happened? I'm only going to add the matrix for this particular route, right? Not for this one. So R4 will advertise the default matrix, whatever the matrix is there for this guy. I'm not doing anything for this person.
So you just removed that link for the
Yeah,
ACL.
I just removed the ACL. I remove the particular route from the ACL. I just no access list, and I'm going to only add. So if you see, I have a single route in the ACL number 1. So I have a single route in the ACL number 1, and in the ACL number 1, what I'm going to call out the 5,000 matrix. So this 5,000 matrix will be added to which route? This route.
Right.
Cool, right?
Yes, yes.
So guys, you can this offset list concept is only comes in the picture whenever you're doing the distance vector routing protocol manipulation, right? Okay. Second thing, it is going to affect on the delay component, and the third thing is that it only increase the mapping. Okay. Same thing, for example, if you want to change the path for all the route, how do I do that? For example, if you have 2,000 per route in your network, if you have a 2,000 route in your network, and I want to change the path for the 2,000 route, simple. 1 minute, let me remove this guy. So for example, if you know manipulate the route for the 2000 network, right, and you don't need to create the 2000 prefixes, we have one option in the Cisco CLI that is called as a what? 0, or select all the network. I'm going to select the 0 over there, and I'm going to call out direction, which what matrix I'm going to apply 10,000 from which interface 0/0. So I'm going to add the 10,000 matrix on this particular interface, right, for all network. So what happened on R1 router? R1 will make this R3 as a rest. So now if you go back to the R1 to show IP route EIGRP, see 4.0.13.3 is west, this west, and this west. So from this side, what happened? It looked like a feasible successor, right? Also, so if you know match the all the route, you can call the ACL number 0, right? And you don't need to create the ACL for that thing, right? It's predefined. Now, take example. This is one scenario over there. Hey, you are not allowed to change. This one. You are not allowed to change. You're not allowed. Come on. You're not allowed to change the delay, bandwidth, or object list to manipulate the path. Then you have another thing that is called as a AD value. And as we know that AD is a what? It's a local to the router. It is a 8-bit number. You can change from 1 to 255, right? It's a local to the router. So if I want to make an effect, right? If I want to make an effect on the router number 1, I want to change on the router number 1. And if you see right now, what's the default AD value for the internal route? 90, and for the external route, what? 170. So right now it's having the 90 over there, right? Let me remove this guy. I have now it's doing the load balancing. Can you see that? And remove the offset list. And remove the offset list. Now it's working fine. Go back to the R1. And what I can do right now, I just go to router number 1, and I see that router EIGRP number 1 distance will be what? Distance that is also called as a AD value. I'm going to say the EIGRP. What for the internal route? 50, for the external route? 100. If I want to change the AD value, see over there, what happened? Do you have any other option? No. Hit enter. So it is a local to the router. It will not exchange in the update packet. So you need to change on the local. If you're going to make an effect on the local router, you have to change on the local router. So if I want to change the AD value, what happened? See, it's changing the AD for all the route and on every interfaces, right? So am I doing the like your path manipulation over there? No, I'm not doing the path manipulation because it's changing the AD value for every route and it enable on every interfaces, right? What I want to make this guy as R2 as the best, right? Primary is the best. So in that case, what we have to do over there, I need to call the the router EIGRP number 1 distance, right? Define the AD50 now. What is the source IP address 12 or 2? Because I'm getting the update whenever the R2 will send the update packet to me, right? Whenever the R2 will send the update packet to me, in this update packet, what is the source IP address? 12 or 2, right? And distance are you are 224 or 0 or 0 or 10, right? So when R2 will send the update packet to the R1, so this is the distance and this is the source, right? So what happened? I said, hey, distance 50, whatever the route that is coming from the 12 or 2, right? Define the wildcard mask and set the AD50 over there. Now what happened? I'm set the AD50 from this side and 90 from this side. Lower 80 is always preferred, right? So R2 will become the best. Can you see that R2 is become the, oh, come on, man. Yep. You see now R2 is become the best for this route. R2 is become the best for this route and R2 is become the best for this route. So what I did, I just need to apply the AD to the particular neighbor, not to the all interfaces, right? I just apply the AD value particular neighbor, not to the all interfaces. So this is how you can change the path based on the AD. But for again, but what happened is changing the AD value for all the route. If you want to make a specific, right? How do I do that? Define the ACL number one. And in the ACL number one, what I'm going to call, now R1 will change the AD value only for the 4.0.0 route, not for the all one. Do show IP route EIGRP. Looks perfect. So 50 is 80 for this particular route. 12 that's the best because 50 is 80 for this for 4.0.0 route, right? And for the remaining route, it's doing the same 80, same metric and doing the load balancing. So guys, it's like, it's totally depend like how your scenarios and situation is coming in your network, and whatever the things they are proposing to you. Hey, these are the things that you have to use and these are the things that you are not going to use, because it's not like that everything you're going to use. Okay, I have an option of delay, bandwidth, offset, this and AD value. I can use any of them. Sometimes some situation is coming where you're not change the AD value. Sometimes some situation is coming where you can change the offset. So you need to you need to pay attention at every situation, right? Okay, what circumstances is there, and whatever the options I have. Cool. Hey guys, let me know if you have any questions. I'm done with your EIGRP, right? Then nothing is there. I'm done. So I've done with all the load balancing mechanism, summarization, all right, named mode, route filtering. I have done with your what we call path manipulations, redistribution, packet tabs. I'm done from, I think so. Anything else that I'm remaining, just let me know.
Sir, so normally in production, AD administrative distance only using for route manipulation in
No,
EIGRP.
what I told you, that it's totally depend on the scenario, right? You can they will give you those to change this guy as well as offset list.
So
Suppose,
offset list also, offset list is changing metric, no? Right?
yeah, offset list is changing the metric. AD is changing the complete AD of the route.
Right. Okay.
Can you open that GNS one?
Mhm.
So here on interface 0 by 1, we are changing the metric, right?
Yeah, interface 0 by 0. I'm
Oh,
applying the neighbor,
yeah,
and this
okay.
command is not there in the book. Write on this command. This command is not there in the book.
Oh, yeah. So, we are changing on the F0 by 1 and F0 by 0, right?
I'm applying to the 12 or 2,
Yeah, only 12 dot. Only
right?
for,
Only 12 or 2,
okay, okay. So
not to
because,
the front end. The default is 90 over there.
okay, no, not, I'm not talking about the distance. I'm talking about the metric.
A metric I'm going to apply on a particular interface.
Yeah, a particular interface, right? So the delay will be changed, right?
Yeah, in that, if you're going to manipulate the offset value, no, it will
Yes.
affect on the delay.
Okay, okay. So if there are some routers behind R3 and you need to ping from R2, right? So R2 will do load balance to reach the routers which are behind R3. Same,
Yeah, of
same,
course. Yes, yes, buddy.
same in the case like R1 to R4. So if
Yeah,
we are changing the delay on R4 F0 by 1 interface, so
I'm
the
not changing the delay. Oh, don't say the delay. I'm changing the offset value, right? Don't change
offset.
the delay, because the delay is a different thing. If
Yeah.
you're changing the offset value, it affect on the delay component. I'm saying that it affect. It's not actually I'm modifying the delay. I'm modifying the offset values.
So you are just manipulating,
Yeah.
not changing the original metric, right?
No, no, no. I'm just adding the whatever the original matrix is coming. I'm just adding over there. If you
Okay.
have a look, 1 minute, I'll remove this guy. Come back to the I want to show IP to EIGRP. Come on. So it's a 43,520, right? I'm just going to router number 4 and I'm going to apply the router EIGRP option list. From which interface 0/1. So I'm just adding the 500 over there, right? So now you should do show IP EIGRP topology. One minute. But there is sync. So I'm adding the 500 on this particular interface, right? So if you go back to the topology table and you can see towards the 13.3, this guy, what happened? 43,500 is the default one, right? This one from the 13.3. And if you see what happened, it's going to add the 7. 500 is adding, right? So it will become the 43,570.
So I'm asking if does applies when I try to reach from R2 to R3 or just it applies for R1, R4 to R1.
Did I call any what I say that? Did I call any particular router number over there?
No.
So it will apply to the MB portion, right? Applying to this particular route.
Okay, fine.
You're not understanding the scenario. Scenario is something like that. I'm applying the 500 matrix option value for which person? EC number 1. And EC number 1, what I'm calling? This guy. So I'm applying this in this matrix to this particular route. So every router, doesn't matter in your network, all the router will have a same behaviors. Can we apply the offset in of course, buddy, if you're going to use the on a router number 1, you can use the inbound direction. For example, you're not allowed to access the router number for them. You have to use the inbound direction or router.
Okay, fine. Got it.
See, I'll tell you one thing. This is the very important. The path manipulation is part is very important, right? For the interview round, it's very important. They will give you the different kinds of scenarios, right? And you have to use the scenario and you have to solve this thing. All good? Any other questions, anyone? Using variance concept, you are using the variance concept, Mohit, you are doing the unequal cost load balancing, not the manipulation. The variance concept is totally different, Mohit.
Sorry, sir. Can you explain one more time the offset 0 concept?
Offset 0 means what? If you see the thing, what I told you that if you have taken, tell me one thing, if you have a 2000 prefix behind the R2, right? 2000 dot. 2000. How many ACL are going to call to match the route? They have a different summon. They have a different networks over there, right? They are different discontinuous networks. Some of guys are the 1.0, 10.0, 100.0, 172, 16 or 150, 190, different route. How many ACL are integrated? It's not possible, right? So you can use the 0 means what? All
Integrated all network.
Right? So I don't need to create any ACL. I just call the offset list 0. 0 means what? All the network. And I'm going to advertise 10,000 matrix from this interface. That's the meaning of 0 concept. But it's not using in the like corporate world. But again, if you want to change, you can change. You need to know that, okay, why should I create the multiple? See, again, if you know, you can. If you don't know, then you don't. You can't do that, right? This is the only one thing is there. In the networking, only you think no. If you know, everything is possible. If you don't, what happened if I'm going to tell you you have to manipulate route for the 2000 sorry, if you want to you want to change the matrix for the 2000 route, you have to get the 2000 ACL and prefix list over there, right? Of course, the prefix list will not work over there. ACL. I can simply get the 0 over there. That's it. So it's totally depend up to you, right?
Without ACL?
Yeah, without ACL.
0 means no ACL.
Yeah, I'm not defining any ACL over there.
So it will change for all.
Yeah.
Okay, thank you.
So in the same case, if I want 50,000 routes to go from R10 to
Then I
set.
have to care. Then you have to care the AC.
Okay, okay. So no, I need so every route we need to define ACI.
Yeah, of course, buddy.
Can or we can select some range like 1 to 100 from.
Yeah, of course. You do have ability to control the wildcard mask, right? Then you
Okay,
can change the some range. But if you have a discontinuous network, how can you choose the range, right? Then you have to get the
okay.
voltage. It's totally depend on the like how the route they have in the routing.
So fine.
Anyone else? Any questions, guys? No? Okay, guys. So here I'm done with the EIGRP. So you tell me, have you watched the whole video that